Okay, so this is question 1 of homework M3, projectiles and vectors. And in this question, we've got at time t seconds, a particle P has position vector r, which is a function of time, and which is relative to the fixed origin O, and r is given by this expression down here, t squared plus 2t in the I direction and t minus 2t squared in the j direction. We need to show that the acceleration of p is constant and then find its magnitude. So to show the acceleration is constant, what we need to do is show that the acceleration is not a function of time. So we take our position vector and we're going to differentiate this to get the velocity vector. So the velocity vector is equal to the derivative of r with respect to time, which is equal to 2t plus 2 in the I direction plus 1 minus 4t in the j direction. We now differentiate a second time to get the acceleration vector. So we're now after the second derivative with respect to time. And we now differentiate these two terms we've got up here. So the derivative of this first term becomes 2 times I, and the derivative of the second term becomes simply minus 4 times j. And there's our acceleration vector. The vector is not a function of time, so we can now say that the acceleration of p is constant. We're now after the magnitude, and the magnitude of A is equal to 2 squared plus 4 squared, and the square root of all of that. 2 squared is 4, 4 squared is 16, so we've now got root 20.